November 24th, 1944. The air raid sirens wailed across Tokyo as something new appeared in the sky over Japan. Not the twin-engine bombers that had launched from carriers in the Doolittle raid 2 years earlier. Not the medium bombers operating from China. These were different. Massive 4-engine aircraft flying in formation at an altitude Japanese fighters struggled to reach, their contrails streaking white across the winter sky. At the Nakajima aircraft plant in Musashino, workers scattered for shelters as the bombs began falling. The raid lasted minutes. Most bombs missed their targets. The B-29 superfortresses, flying their first mission against the Japanese home islands, turned and headed back toward their base on Saipan, over 1,500 miles to the south. One didn't make it back. The aircraft, damaged by flak over the target, began losing altitude somewhere over the Pacific. The crew fought to keep it airborne, but the math was unforgiving. With fuel streaming from punctured tanks and one engine dead, they couldn't reach Saipan. The pilot turned toward the closest land. Not American-held territory. Not neutral ground. The southern coast of Kyushu. They almost made it to the water. The B-29 came down in a rice field 3 miles inland from the coast, the impact tearing off the landing gear and ripping open the fuselage. Some of the crew survived the crash. Japanese soldiers reached the site within an hour. By evening, what remained of the aircraft was under guard, and word had reached Tokyo. Engineers were coming. Yoshiro Nakamura stood in the rice field 2 days later, staring at the wreckage. He was 41 years old, a senior engineer at Nakajima Aircraft Company, and he had spent the last 15 years designing bombers for the Imperial Japanese Navy. He had worked on the G-4 Tim, the Type 1 attack bomber the Americans called the Betty. He knew every compromise, every limitation, every desperate measure they'd taken to Batuzi. Squeeze more range and payload from engines and airframes that were already pushed beyond reasonable limits. He thought he understood what the Americans were capable of. The wreckage in front of him suggested he'd been wrong. The tail section had broken off on impact but remained largely intact. Nakamura walked toward it slowly, his assistant trailing behind with a notebook. Even destroyed, even half buried in mud, the scale was staggering. The vertical stabilizer towered above him, taller than a 2-story building. The horizontal stabilizers stretched wider than the entire wingspan of some Japanese fighters. He'd seen the intelligence reports. He'd read the estimated specifications. Wingspan of 141 feet, length of 99 feet, maximum takeoff weight over 120,000 pounds. Numbers on paper. He'd assumed they were exaggerated, the way intelligence estimates always were. American propaganda, perhaps, designed to intimidate. But here was the physical reality, and if anything, the reports had understated it. Nakamura climbed onto what remained of the wing root, careful to avoid the jagged aluminum edges. His hand touched the skin. He stopped, pressed his palm flat against it, knocked gently with his knuckles. "Measure this," he said quietly. His assistant produced calipers. The measurement took several attempts. The aluminum skin was thicker than anything Nakamura had seen on a production aircraft. Not by a little. The wing skin on a G4M measured 0.04 inches in most places, sometimes thinner to save weight. This was nearly double that thickness, and the aircraft still flew 3,000 miles. They moved methodically through the wreckage over the following days. Each discovery added to a picture that Nakamura found increasingly difficult to accept. The Americans hadn't just built a bigger bomber. They'd solved problems that Japanese engineers had considered unsolvable. The engines were Wright R-33 fibers, Cyclones, 18-cylinder radials, each producing 2,200 horsepower. Nakamura had his team carefully measure the cylinder dimensions, examine the supercharger design, study the cooling fins. Japanese engines of comparable size produced 1,500 horsepower on a good day, and the Homar engines that powered many Japanese fighters had earned a reputation for catching fire or seizing up after a few dozen hours of operation. These American engines had flown over 1,500 miles to Tokyo, fought through flak and fighters, and nearly made it back before the damage became fatal. The quality of the metallurgy was immediately apparent. The cylinder walls showed almost no scoring. The bearings, even after the violent impact, showed minimal wear. "How many hours do you think these engines had?" his assistant asked. Nakamura shook his head. Japanese engines were typically pulled for overhaul after 150 hours. 200 if they were lucky. These looked like they could have run for 500 hours or more, but it was inside the fuselage that the real shocks waited. The forward section had crumpled on impact, but the mid-fuselage was intact enough to enter. Nakamura climbed through a tear in the skin and found himself standing inside a space that seemed impossibly large for an aircraft. The fuselage diameter was over 12 feet. A man could stand upright, could walk from the front to the back without crouching, and it had been pressurized. Nakamura had read about this. The intelligence reports mentioned that B-29 crews flew without heavy heated suits, even at 30,000 feet. He'd dismissed it as unlikely. Pressurizing an aircraft that size seemed like a fantasy. The engineering challenges were immense. The weight penalty would be enormous. But here was the evidence. Thick, reinforced bulkheads at the front and rear of the cabin section, sealed doors with heavy rubber gaskets, small, thick windows. He examined the seals carefully, noting the quality of the rubber, the precision of the machining. Japanese manufacturers struggled to produce reliable rubber gaskets for fuel systems. The Americans were using them to seal an entire cabin at altitude. The implications were staggering. A pressurized cabin meant the crew could operate efficiently at altitudes where Japanese fighters struggled to climb. Meant they didn't suffer from hypoxia or cold. Meant they could fly longer missions without the physical deterioration that affected crews in unpressurized aircraft. Then he found the gun turrets. There were 5 turret positions visible in the wreckage. 2 on top, 2 on the belly, 1 in the tail. Each turret held 2 50-caliber machine guns. 10 defensive guns total, plus a cannon in the tail position of some variants. But it was how they were controlled that made Nakamura stop and stare. The guns weren't manually operated. There were no gunners sitting in the turrets, freezing in the wind, struggling with manual controls. Instead, there were sighting stations inside the pressurized cabin, small positions with computing gun sights. The gunners sat in comfort, looking through clear sights, and the turrets moved remotely. Nakamura found the control system in the wreckage, bundles of cables running through the fuselage, electric motors on the turret mounts, and most remarkably, a central fire control computer, an analog system that calculated lead angles, adjusted for aircraft speed and altitude, and allowed any gunner to take control of multiple turrets. He'd never seen anything like it. Japanese bombers relied on hand-operated machine guns, the gunners exposed in open positions or cramped blisters, manually calculating deflection angles, fighting the cold and the wind and the lack of oxygen at altitude. The Americans had turned defensive gunnery into a centralized, computer-assisted system. "This is a General Electric design," one of his team said, examining the turret mechanism. "The manufacturing precision is remarkable." Nakamura nodded slowly. Every component they examined showed the same characteristic: precision manufacturing, quality materials, attention to detail that suggested unlimited resources and time. The wiring was neatly bundled and secured. The hydraulic lines were properly supported and protected. The structural members were uniform and showed no signs of the shortcuts that plagued Japanese production. A Japanese bomber was a collection of compromises. Lighter materials to save weight, thinner skin to reduce cost, simpler systems because complex ones couldn't be manufactured reliably. Every design decision was a trade-off between capability and what could actually be produced. This aircraft seemed to have been designed without such constraints. Over the next week, Nakamura's team catalogued everything they could. They measured dimensions, photographed components, sketched systems. They found the oxygen system, with its large capacity bottles and efficient regulators. They found the heating system that kept the cabin comfortable. They found the sophisticated radio equipment, far more advanced than anything in Japanese service. They found the bomb sight, a Norden device, partially damaged but still recognizable. Japanese bomb sights were crude by comparison, requiring significant skill to use effectively. This was a precision instrument designed to put bombs on target from high altitude. They examined the bomb bay, large enough to carry 20,000 pounds of ordnance. The G4M could carry 1 torpedo or 2,000 pounds of bombs. The B-29 could carry 10 times that load the same distance. Every measurement, every observation added to the same conclusion. The gap wasn't small. It wasn't a matter of Japanese industry catching up in a year or two. This was a generational difference in capability. Nakamura had his team examine the aluminum alloys used in the airframe. Japanese metallurgists were constantly struggling with aluminum supply and quality. The Americans seemed to have aluminum in abundance, and the alloys were superior. Stronger, more corrosion-resistant, more consistent. Where do they get all this aluminum? His assistant wondered aloud. Nakamura didn't answer. He was thinking about the scale of American production. Intelligence reports suggested they were building hundreds of these aircraft. Not a handful for special missions, hundreds, perhaps thousands. Each one represented more aluminum than a Japanese factory might see in months. Each one had 4 engines that were more reliable than anything Japan could produce. Each one had systems and equipment that would take Japanese industry years to develop, if they could develop them at all. On the 8th day of examination, a naval officer arrived from Tokyo. He wanted a briefing on what had been learned. Nakamura stood in a tent near the wreckage site, his notes spread on a folding table. The officer was young, perhaps 30, with the confident bearing of someone who hadn't yet seen his assumptions destroyed. "Can we duplicate this?" the officer asked, after Nakamura had walked through the major findings. The question hung in the air. Nakamura looked at his notes, at the measurements and sketches and photographs, at 8 days' worth of discoveries, each one revealing how far behind Japanese industry had fallen. The pressurization system alone would take years to develop, he said finally. "We don't have the rubber quality for the seals. The turret control system requires manufacturing precision we can't achieve in quantity. The engines—" He paused. "The engines represent metallurgy we haven't mastered. But theoretically," the officer pressed, "if we had time and resources." Nakamura thought about the question, thought about the Japanese aircraft industry in late 1944. Factories bombed, skilled workers conscripted, aluminum scarce, fuel scarcer, quality, control deteriorating as production was rushed to replace losses. "Theoretically," he said slowly, "we could perhaps develop similar systems over 5 to 10 years, with unlimited resources and no interference. But we don't have 5 years, we don't have unlimited resources, and the Americans are already building these in quantity." The officer's expression hardened. "That's defeatist talk." "That's reality," Nakamura replied quietly. "This aircraft represents an industrial capacity we cannot match. They're not just ahead of us in design. They're operating on a completely different scale of production." He gestured toward the wreckage visible through the tent opening. "Every component in that aircraft is manufactured to a higher standard than we can achieve. The quality control is better. The materials are better. The systems integration is better, and they're producing them at a rate we can't approach." The officer left without another word. Nakamura returned to the wreckage. His team had found something new. In the remains of the cockpit, they'd discovered the pilot's manual, partially burned but readable. One of the engineers who read English was going through it, his expression growing more troubled with each page. "What is it?" Nakamura asked. "The procedures," the engineer said. "The checklists. Everything is standardized, documented. There are specific procedures for every phase of flight, every emergency, every system." He held up the charred manual. "Japanese pilots learn through experience and informal instruction. This," he shook his head, "this is systematic training, everything written down, nothing left to memory or tradition." It was another small piece of a larger picture. The Americans hadn't just built a better bomber, they'd built a system for operating it efficiently. Training was standardized, procedures were documented, maintenance was systematic. Every aspect of operation had been thought through and optimized. Japanese military culture relied on fighting spirit and individual skill. The Americans had industrialized warfare itself. Nakamura spent one more day at the site, making final measurements and notes. On the last evening, he stood alone near the wreckage as the sun set over the mountains. The rice field was churned to mud by all the foot traffic. The B-29's remains looked strangely small now, after days of close examination. Just twisted aluminum and broken components, but he knew what it represented. He thought about the G-4M bombers he'd helped design. They'd called it the Type 1 land attack aircraft. The Americans called it the Flying Lighter because it caught fire so easily. They'd sacrificed armor and self-sealing fuel tanks to save weight, to squeeze out more range. Japanese crews flew in aircraft they knew were death traps because that was the only way to achieve the performance requirements with the engines and materials available. The B-29 needed no such compromises. It had armor. It had self-sealing tanks. It had all the defensive systems, all the crew comfort, all the safety features, and it still outperformed Japanese bombers in every category. That was the difference. Not just better engineering, better everything. Better materials, better manufacturing, better resources, better systems. A young engineer approached, one of the newer members of the team. "Sir, do you think we can learn from this? Apply these lessons to our own designs?" Nakamura considered the question carefully. He thought about the factories back home, struggling to produce aircraft with increasingly scarce materials. He thought about the engine problems that plagued every Japanese design. He thought about the pilots being sent into combat with minimal training because there wasn't fuel to spare for practice. "We can learn," he said finally. "But learning and implementing are different things. To build an aircraft like this requires an industrial base we don't have. Raw materials we don't have. Time we don't have." He looked back at the wreckage one last time. "What we've learned here is that we're not fighting an enemy that's slightly ahead of us. We're fighting an enemy that operates on a completely different level of industrial capability. They can afford to build aircraft like this. They can afford to lose aircraft like this. They can afford to do it again and again." The young engineer was quiet for a moment. "What do we do with that knowledge?" "We document everything," Nakamura said. "We write detailed reports. We make precise measurements. We provide the facts to those who make decisions." He paused. "And we hope someone in Tokyo is willing to face what those facts mean." The team packed up the next morning. The wreckage would remain under guard, but the technical examination was complete. Nakamura carried boxes of notes and photographs back to Tokyo, a comprehensive documentation of everything they'd found. His report was thorough and honest. He detailed the technical superiority of the B-29 in every category. He noted the manufacturing quality, the systems integration, the evidence of vast industrial capacity. He provided specific measurements and comparisons to Japanese aircraft. He concluded with an assessment that he knew would be unwelcome. The technological gap was too large to bridge in the time available. Japanese industry could not duplicate these capabilities with current resources. The B-29 represented a level of industrial development that Japan could not match. The report was filed and classified. Nakamura returned to his work at Nakajima, designing improvements to existing aircraft, trying to squeeze more performance from limited materials and troublesome engines. The B-29s kept coming. Through the winter of 1944 and into 1945, they appeared over Japan in growing numbers. First dozens, then hundreds. They flew at altitudes Japanese fighters struggled to reach. They absorbed damage that would have destroyed Japanese bombers and kept flying. They dropped thousands of tons of bombs on Japanese cities and industrial centers, and Japanese engineers in factories across the country looked up at the contrails and understood what Nakamura had seen in that rice field. They were fighting an enemy whose industrial capacity was so far beyond their own that the gap couldn't be measured in years. It could only be measured in the difference between what was possible and what was not. By March of 1945, B-29s were flying low-level incendiary raids, burning Japanese cities in single-night attacks. The pressurization systems and high-altitude capabilities that had so impressed Nakamura were barely being used. The Americans didn't need them. Japanese air defenses had been so degraded that the B-29s could operate at medium altitude with near impunity. Nakamura's factory was hit in April. He survived, but the plant was destroyed. Production stopped. Not that it mattered much by then. There was little aluminum left, less fuel. Skilled workers had been drafted or killed. The aircraft that were still being produced often had such poor quality control that they were dangerous to their own pilots. In the ruins of the factory, Nakamura thought back to that day in the rice field, to the moment he'd first touched the thick aluminum skin of the B-29's wing and realized how far behind Japan had fallen. He'd known then, in November of 1944, what the outcome would be. The physical evidence had been undeniable. The war ended in August. Nakamura survived. In the years after, he would occasionally see photographs of B-29s, either in newspapers or in the American Occupation Force's materials. Each time he remembered standing in that muddy rice field, measuring and documenting and slowly understanding that some gaps are too wide to bridge. The B-29 that crashed in Kyushu had been one of over 3,000 B-29s built during the war. The Americans had lost over 400 of them in combat operations, a loss rate they could sustain because they were producing them faster than they were being shot down. Japan, in the same period, produced fewer than 70,000 aircraft total of all types, with declining quality as the war progressed. That was what Nakamura had seen in the wreckage. Not just a better bomber, a demonstration of industrial capacity so vast that resistance was mathematical impossibility. The Americans could afford to build aircraft with pressurized cabins and remote-controlled turrets and redundant systems. They could afford to make them well. They could afford to lose them and build more. Japan couldn't afford any of it. The young engineer who had asked Nakamura what they should do with the knowledge they'd gained had never made it out of the war. He died when his factory was bombed in June of 1945. But his question remained relevant. What do you do when you discover that the gap between you and your enemy isn't a matter of effort or determination or fighting spirit? What do you do when the physical evidence makes it clear that you're not just behind, but operating in a different category entirely? You document it, you report it, you hope someone listens. And when they don't, you watch the contrails in the sky and wait for the inevitable.